Hello guys, I hope all of you are doing well. It's nice meeting you again for the semester two of MSc Cybersecurity and Digital Forensics. So this time I'll be taking malware forensics or malware analysis. So last week we were supposed to start a class, but I had already asked you to cover module one and two, which is basically just an introductory, theoretical introductory to malware analysis. So today I wanted us to cover module one, two, three, so that at least we'll be able to go deeper, understand malwares, understand the malware analysis techniques, and be able to understand some of the tools that are used in malware analysis. I think we'll use the same procedure that we were using last semester. So weekday we cover the theory, then over the weekend we can be able to cover the practical. So for malware analysis, for you to be very good in it, it's good at least you understand the practical element. So it's good at least if by any chance you have a good computer, you ensure that at least you have a virtual machine that we will take you through how to configure a virtual machine. That will be an isolated environment for you to be able to test different types of malware. So malware is just a software that damages or disables computer systems and gives limited or full control of the system to the malware creator for the purposes of theft or fraud. It's just any solution, any software solution that disables a computer system and gives limited or full control of the systems to the malware creator for the purposes of theft or fraud. There are different types of malware that include viruses, worms, trojans, and etc. that we are going to explore so that at least we understand how do they work and how do they infect a computer system. There are different ways that a computer gets infected by a malware. So most of the time they are using instant messenger applications and internet relay chats whereby you are able to download maybe something like Telegram. Sometimes they transfer malware there. So you think that you are downloading maybe a legitimate application, but it's not. It's just a malicious file. There are also removable devices also are used to infect computer systems. So malwares are used to get into computer system through removable devices, whereby by any chance you have maybe a USB drive that is already infected, then if you connect to any other computer system, you are able to transfer the malware. They also use links and attachments in email. Sometimes they always manipulate the mindset of a human being. So they always go, maybe they send an email, then in that email, there is an attachment of a malicious file. So through links and attachments, you click on the link or maybe an attachment on an email, then it redirects you maybe a malicious web page, or you are able to download a malicious application into the computer system. We have also need bias file sharing. Sometimes organizations always set up maybe FTP servers for sharing information. So sometimes you can find yourself, you are downloading maybe a malicious file from file sharing. They also use fake programs and free software. So you might be thinking that you're using a free software, but in essence, it's not a free software. It's a tool that has been programmed by malware actors to be able to transfer maybe your files, or either that freeware that you're using is able to download other malicious files to the computer system or link you to other sites that are malicious. Through browser and software bugs, majorly malwares are transferred through browsers, whereby you might be on a web page, then you are redirected to another web page that could be malicious. So, and also software bugs, maybe you are able to add a bug, maybe it's just an error in a computer system. So you might be thinking that the software has a bug, but it's not a bug. It's a malicious software that they want you to download so that at least it gets into your computer system to be infected with the malware. Downloading files, games, and screensavers from untrusted sites. Sometimes some people they always go to untrusted sites to download the games, files, and screensavers. But when they download those files, they are not legitimate applications that they were thinking they were. They are just malicious software that they are bringing into their computer systems. So we have different types of malwares that exist there. We have backdoors. They're just types of malwares that allows an attacker to control the computer system. We have botnets, or these are a group of computers that have been infected by malwares and they are being controlled by the malware actors. So they can be used maybe to launch distributed denial of service attacks to computer systems, We have downloaders, which are just malicious code that exists only to download other malicious code to the computer system. They are used when an attacker first gains access to the computer system. We have information stealing malwares where we have sniffers. So their work is just to sniff the traffic of communication, maybe between two devices. So their work is just to sniff that traffic. Then the malware developers are able to get the network traffic. So they can be able to analyze the sniffed traffic so that at least they can be able to understand what was being transferred over the network. We have keyloggers. These are type of malwares that majorly they are installed in computer systems. So their work is just to collect any keyboard entries that you enter. Majorly their key interest is to collect the passwords of computer system. Then also we have password hash grabbers. So their work is just to grab the hashed passwords within the computer system. So they always target the hashed passwords that are stored in the RAM, and also the one that is stored maybe in the registry files, like the SAM files. So it's a malicious file, maybe it gets into your computer system, don't know if it exists. So its work is just to ensure that it collects the hashed passwords and sends it out to the malware actor. So those are information stealing malwares. We have launchers. These are malicious programs that are used to launch other malicious programs, often use non-traditional techniques to ensure steal or greater access to a computer system. So they remain still that you are not able to identify that there is a malicious software within the computer system. And also they have a greater access to computer system. Maybe they are able to put themselves as auto-starting applications. So when you power on the computer, you find that the application has already auto-started. We have also rootkits, which are malware that conceals the existence of other code. They are usually paired with backdoors to allow access to computer systems. We have mass malware. These are just malwares that are intended to infect as many machines as possible. They are the most common types of malwares that are currently being used by malware threat actors. They develop this one because they are targeting as many machines as possible by any chance that malware spread over the network. There is targeted malware tailored to a specific target. Maybe you can have maybe a malware that you are targeting only a specific organization. Maybe there is some data set that you want. So the malware actors can come up with that malware. So they develop a malware that is only targeted for a specific organization. So it's very difficult to detect such a malware and prevent and remove it. And it requires also advanced analysis. An example is Stuxnet malware. We have spam sending malware. Attackers rent machines to spam, to spammers, so that at least their work is just to send spamming messages. We have worms and viruses, malicious code that can copy itself and infect additional computer systems. A malware always has different components, and those components are the ones that aids its functionality on the computer system. So components of malicious software rely on the requirements of the malware author, who designs it for a specific target to perform the intended tasks. So they always have a crypter, which is a software that disguises malware as a legitimate product through encryption or obfuscation, thus protecting it from the detection by security programs. We have download is a type of a trojan that downloads other malware from the internet onto the PC. Usually attackers install downloaders software when they first gain access to a system. We have a dropper, which is a type of a trojan that installs other malware files on the system, either from the malware package or the internet. We have an exploit, a malicious code that breaches the system security via software vulnerabilities to access information or install the malware. We have injector, which are programs that injects its code into other vulnerable running processes and changes the way of execution to hide or prevent it from removal. We have obfuscator, a program that conceals its code and intended purpose by various techniques, thus making it hard for security mechanism to detect or be able to remove it. We have a packer, which is a program that allows to bundle all files together into a single executable file via compression in order to bypass security software detection. We have a payload, which is a piece of software that allows to control a computer system after it has been exploited. We have malicious code, a command that defines malware's basic functionalities, such as stealing data and creating a backdoor. Then we have a fileless malware, which is a group of malware that do not write any file to the disk and use only approved Windows tools for installation and execution, thus circumventing security programs and application whitelisting processes. So those are the key components that different malwares use to be able to compromise computing system. So by any chance, it's a malware. Today, the malware developers, they're coming up with sophisticated malwares that computer system, maybe the antiviruses, the EDR, they are not able to detect that it's a malicious file. This they are doing through using packers or obfuscators where they are able to compress the code of a malware. So an antivirus system is unable to understand the code because most of the time antiviruses always detect a malicious file based maybe on network signatures or behavior signatures that are host-based signatures. So based on the signatures that he is able to detect if this file is malicious, that's when an antivirus or EDR is able to detect that this is a malicious file. So most malware developers are coming up with components that ensures that the malware remains stealth and cannot be detected by the computer system. So they are using different techniques which we will be able to go through because we have to understand how can we be able to maybe to understand a malware that has been compressed or packed, or a malware that the code is hidden or the code is encrypted. How do we go about that? So there are common techniques attackers use to distribute malware across the web. So most of the time they are using black hat search engine optimization, where majorly they are able to rank malware attacked pages in search engines page results. So when you are searching maybe something on the web page, you are thinking maybe you're searching something, then the first ones that comes appears first on the web page, they are malicious files. It's not something that you are looking for. They're also using malvertising, where they embed malware in ad networks that display across hundreds of legitimate high traffic sites. So they use that, it's like they're advertising the malware. So they always put malwares in high traffic sites, maybe sites like where there are so many people who access daily, like maybe on Facebook. If you search maybe Facebook, they try to put specific malwares there. So they display it there. By any chance, you think it's just a legitimate web page, but sometimes it's able to redirect you to malicious web pages. They're also using compromised legitimate websites. Sometimes they compromise websites. Maybe they are using cross-site scripting so that they redirect the user to other web page that is malicious. So you might be accessing maybe a web page, then you think that it's a legitimate web page, but it's redirecting you to other malicious web page so that at least you can be able now to access the malware. They are also using domain shadowing, stealing domain account credentials by phishing to create multiple subdomains that direct traffic to landing pages, hosting, and exploit kit. They are also using social engineered clickjacking, tricking users into clicking on innocent looking web pages. Sometimes I've seen those who are watching football online. There are some web pages when you click play, you want now the game to start, you click on play, then it redirects you to another web page. So those web pages that it's redirecting you to, it might be having an exploit kit, or it may allow you now to download other malicious applications into your computer. Sometimes it auto downloads. So you don't know that it was auto downloading. Sometimes you can find your computer is filled with unknown downloads. So those unknown downloads might sometimes be malicious files. They're also using spear phishing sites. They mimic legitimate institutions in an attempt to steal login credentials. So they can use maybe come up with a web page. You might be thinking it's maybe an OUK web page, but it's not a OUK web page. So it redirects you to that page. You are trying to log in as a student, thinking that maybe you're logging on Thomas, but it's just a mimicked web page. So when you enter those login credentials, they're able to get your login credentials. There is drive-by downloads where viruses exploit flaws in our browser software to install malware just by visiting a web page. So sometimes you visit a web page, but there is flaws in that browser that are exploited. So once they are able to exploit that browser, they can be able to allow you now to download some files that are malicious. There is mouse hovering, malware getting auto-executed when the user hovers his mouse pointer over any hyperlinked text or picture in a malicious PowerPoint slideshow. So sometimes they always put malicious maybe a web page or an image in PPTs. So when you move your mouse like this, provided you have accessed it, automatically it's executed. So we have to understand malware analysis is an important aspect of incident response. When a computer system, maybe you have found a malicious file in the computer system, you need to know, you maybe as a security expert or someone working within an organization that wants to understand, you have to understand if an attacker, did he implant or a rootkit maybe or a trojan on your computer system? Is the attacker really gone? Or what did the attacker steal or add the computer system, and how did the attack get into the computer system? So you have to do root cause analysis during incident response. And this is important. That's why we are studying malware analysis. So malware analysis tries to answer for you these questions after an attack has taken place on a computer system. So you have to understand if the attacker implanted a rootkit or a trojan, what type of malware, if maybe the cyber threat actor used to compromise the computer system, and you have to do analysis so that at least you understand, is the attacker really gone? What did the attacker steal or add to the computer system? And how did the attack get into the computer system? Those are the key things that you will be able to understand when you're doing malware analysis. So malware analysis or malware forensics is just a way where you deal with identifying and containing malicious code and examining its behavior in a controlled environment. So malware forensics just deals with identification and containing malicious code and examining its behavior in a controlled environment. Like during an incident response, maybe an incident has been reported, you have identified maybe there was a malicious application or software within the computer system. So your work as a malware analyst is to identify what was the key application that was malicious. Then from there you containing, like you ensure that does not continue having its activities on the computer system. So maybe you remove the infected server from the network so that the malware does not spread all over the network. Then from there now you analyze the malware, the suspicious application that you have identified, so that at least you are able to understand its behavior. And you do that in a controlled environment. So performing malware analysis enables investigators to know the type of malware, how it works, its behavior, and its impact on the target system. You can use a set of tools and techniques to conduct static analysis, dynamic analysis of the malicious code. We're going to study more so that at least we understand at static level what will we be doing, and at dynamic level what will we be doing. But malware analysis is just dissecting the malware to understand how it works, how to identify it, how to defeat it or eliminate it from a computer system, which is a critical part of incident response. Why do we have to analyze the malware? Majorly is to determine what exactly happened to the computer system, to determine the malicious intent of the malware, to find out the indicators of compromise, to determine the complexity or level of the intrusion, then to identify the exploited vulnerability, to identify the extent of damage from an intrusion, to catch the perpetrator accountable for installing the malware, to find signature for host and network-based intrusion detection systems. Because you need, even if it's a new malware that has been identified, we need its hash. So once we have the hash, maybe it could be used as a signature to be added on host or network-based intrusion detection system so that they can be able to detect that malicious software next time. There are several challenges that we face when you're doing malware analysis currently, because you have to understand the accuracy of the analysis process. Sometimes you might not be accurate in whatever you'll be able to find as the maybe behavior of a malware, detection of malware pieces and traits. You might not be able to understand all the malware detection techniques. So there are some pieces and traits that you might not be able to understand while you're doing malware analysis. Because when you're doing malware analysis, you have to understand deeply its behavior. So once you understand its behavior, you have now to classify that malware. But sometimes you might not be able to do that. Amount of data to be analyzed, with the data is growing. Like today, maybe you are running a server, maybe that is running on RAID, maybe RAID 5, that has more than 2 terabytes. And then there is a malicious file that is running there. How can you be able to analyze the entire data set so that at least you can be able to identify the activities of the malware, or maybe the files that were changed or modified or altered when the malware impacted that system? So the data is too much to be analyzed. Changing technologies and dynamics of malware creation and propagation. Now we are in the era of AI, that malware actors are now creating sophisticated malwares that are encrypted, they are packed, they are obfuscated. So the code is compressed. Analyzing to understand that malware now is a challenging task. It's not an easy thing. Anti-analysis procedures such as encryption, code obfuscation, and deletion of records. You can find some malwares, they always delete everything on the computer system. So even if you are analyzing, you might be able to extract the malicious software or application that was being executed on the computer system, but you might not be able to understand the changes that it was able to make on the computer system, because everything might have been deleted and you are unable to recover that. So during malware analysis, you have to identify and extract the malware. So if a user has reported a suspicious activity on his or her system, you must examine the following areas of the compromised system to find traces of the malware installation. So when you are doing installed programs, when you analyze the installed programs, you'll be able to see if by any chance there is any suspicious installed application. When you analyze suspicious executables, when you go to a prefetch file, you'll be able to see the files that were executed in a day. So you'll be able to analyze the executable files within the registries. Then you'll be able to see, maybe you might find an executable file that you suspect it was malicious, that was not supposed to be executed on that system. Auto starting location, when most of the malwares, they always try to hide themselves. So they want to auto start. So you go to auto start, they always change the registry keys so that they can be allowed into auto start. So when you analyze, sorry, the power is about to go. Oh, my computer power is down. So auto starting location, when you analyze the auto starting applications, you are able to see maybe some malicious application could be there that is auto starting in the computer system. Schedule the jobs, sometimes you can be able to see maybe on queue of the applications that are running or processes, you can be able to see that there is a scheduled job that is supposed to be executed. Some malwares, they always maybe execute at a specific time. So it can get into the computer system, then its execution is timed or scheduled. So it's good to analyze the scheduled job so that at least you see maybe there's some malwares that are scheduled to be able to perform some activity at specific times of the day. Running services within the computer system, some services always open entries for malwares. So you can be, maybe you have deactivated maybe an RDP service on the computer system, then some malwares come and start it. So some auto start up services within the computer system that should not be auto started. So analyzing the services also can be able to tell you what is happening in the computer system. Modules also, it will be able to tell you what are the loaded modules in the computer system. Logs, computer logs also, when you analyze them, they'll be able to tell you which malicious activities were taking place on the computer system. Maybe login and access logs within the computer system, file integrity logs on the computer system. It will be able to show you which files were accessed on the computer system. User accounts and login activities, you can be able to identify maybe if there were new user accounts that were created in the computer system of that suspicious activity that could have happened maybe on a server. File systems also, when you analyze the file system, you'll be able to understand the changes in the file system. By any chance there was any deletion, alteration, or modification of the file system. Registry entries, majorly it keeps the log activities of the computer usage. So if you analyze the registry entries, you are able to see any changes that were done at the registry level. Application traces, when you analyze the application traces, maybe in app data, you will be able to understand maybe there are some traces of remnants of applications that were tried to be executed on the computer system. You can also analyze the restore point. Maybe when you go to restore point, you'll be able to see maybe there is an activity that took place and there is a specific restore point that was there. On which day was that restore point? Because by any chance there is a malicious activity that has happened in the computer system, the system always creates restore points that you can be able to restore the system to a clean environment. So you can analyze the restore point so that at least you're able to see by any chance there is a specific restore point that is there, so that at least you return the computer to a clean status that it was before. So the key tools that are used majorly for identifying all the activities, we have bulb wizard, and Cryptam malware document detection suite to extract patterns from malicious files for investigation. You can perform static and dynamic analysis together to identify the intent and capabilities of the malware. So how do we set up a malware analysis lab? Majorly malware analysis, you have to, when you are running maybe testing a malicious application that you have identified on the computer system, you have to ensure that you run it in a controlled environment that ensures that the malware does not spread to the network, does not spread to the other computer systems, and does not spread to your system that you analyze. So therefore, you need a dedicated laboratory system, which is that is required, that can be infected within, while keeping the production environment safe from malware infections. So best way to set up the malware forensic lab is always to use a virtualization software. Maybe you use a VirtualBox, VMware, or Parallels, or you can use a hypervisor. Then you have to isolate it from the production network to prevent the spread of the malware. So there is some importance that is there when you're analyzing malware in a virtual machine. So it protects real systems and network from being infected by the malware. And analysis, it's easy to analyze malware interaction with other systems, allows screen capturing during analysis, ability to take snapshots of the laboratory system, which can be used to easily revert to a previous system state, snapshot points. So when you're analyzing in a virtual machine, you can create a snapshot. So once you run a malicious code, or you are testing a malicious software, after it has been executed, you have identified its activities, its behavior, you have understood that, then you can be able now to return that virtual machine to a specific snapshot that was clean before the malware was executed. For you to prepare the malware analysis lab, you have to allocate a physical system for the analysis lab. You have to install a virtual machine, maybe a Hyper-V, VMware, or VirtualBox on the system. You have to install guest operating system in the virtual machine, such as Windows and Linux. Most of the time in Windows, we do malware analysis majorly on Windows 10 or Windows 7. Then Linux, we are using Remnux, which is a tool specifically tailored. It has all the tools that are needed in Linux version for malware analysis. So these machines serve as forensic workstation during the analysis of the malware. We have to isolate the system from the network by ensuring that the network interface card is only on host only mode. So this one ensures that the virtual machine does not connect to the network. So by any chance now you're executing the malware, it's just within the virtual machine. You have to simulate internet services using tools such as INetSim. So INetSim just provides a virtual network interface. So by any chance you're executing a malware, you are able to monitor its maybe DNS interactions, the IP interaction, and also the ports the malware is able to interact with. You have also to disable shared folders and the guest isolation. When by any chance you have shared folders, the computer system always tries to locate all the shared folders. So if you have shared the folder with your host computer system, then it means that the guest is able to write the same folders that you have shared. So by any chance a malware is infecting the virtual machine and you have shared folders, then it means also some of the shared folders of the host system will be infected. So you have to ensure that disable that. You have to install malware analysis tools, which I'm going to take you through some of the tools that we are going to use, so at least we learn how to be able to analyze the malwares. We have to generate the hash value of each operating system and the tool, so that at least at the end, we have to compare the hash value of the system before executing the malware and after executing the malware. So that one helps you to be able to see that the malware maybe made changes the computer system. If if the hashes are different. We have also the copy the malware collected from the suspect machine on the forensic workstation for analysis. So the workstation here, forensic workstation, we're calling that, is the virtual analysis lab that you have created in a virtual machine. So there are some tools that you're going to use for malware analysis. We need hypervisors, which are just like VirtualBox, the parallel desktop VMware, just to provide a virtualized environment for malware analysis. We need network and internet simulation tools. These just simulate the network as it is, so that at least you can be able to ensure that the malware is not able to spread outside the network, and also you are able to analyze its activities to understand it. So you can be able to use NetSim, NS3, the Riverbed modeler. You can be able to use also WorldNet. You have to be using screen capture and recording tools so that at least you are able to see, by any chance you are able to monitor the behavior of the malware. You can be able to take the screenshot because you are needed to document malware analysis reports that shows the activities of the malware, so that at least someone else, by any chance you're presenting a report, they are able to understand the malware analysis report. So there is Snagit, there is Camtasia, there is ASVID. Those are the tools that majorly you're going to use to be able to take screenshots or screenshot. Then we have also OS backup and imaging tools. We have Jenny Backup Manager Pro, Macrium Reflect Server, R Drive Image, or Disk Image 16. These are important for you to be able to do OS backup. So by any chance now the malware has been executed on the computer system, still you can be able to go back to the backup so that at least you continuously use the lab that you're using. There are several rules that you have to follow during malware analysis. So during malware analysis, pay attention only to the key features instead of looking at each and every detail. So by any chance you have identified maybe the activities of what you're going to analyze is maybe you have identified in the running processes it had created other files. So focus on the created other files and also the executed program that you are able to identify. And also you ensure that sometimes they could be a new malware. So if by any chance you are now going to focus on everything, you might find yourself, you are testing a malware that when you test maybe publicly, the malware developers are able to understand that this malware has been identified and it's being investigated. So sometimes they are able to auto delete by any chance they have access to the computer system. So remotely they can be able to wipe the malware so that you as a malware analyst, you do not understand its functionality. So you have also always to try different tools and approaches to analyze the malware, as a single approach may not be helpful. You have to identify, understand, and defeat new malware analysis prevention techniques. Those are the key rules that you're going to follow during malware analysis. So during malware analysis, we have two key areas that you're going to focus on. We have static malware analysis, whereby you are able to analyze the malware without executing it. So you just analyze the code of the malware so that you understand the binary code without its actual execution on the computer system, just to have a better understanding of the malware and its purpose. You can use disassemblers such as IDM Pro or OLIDBG. Those are the key tools that you use to disassemble a malware. So you just dissect it into a code level so that at least you go through the code, so that at least you can be able to understand the functionality of that malware based on the flow of the code. Also, at static basic malware analysis, we always have other tools whereby you can now be able to understand the strings. Strings are just values within the malware. Sometimes it can be able to lead you to understand maybe there are some URLs that this malware contacts, or maybe the IP addresses, or maybe there are some key terms that you can be able to see, maybe passwords, maybe CMD. So it just gives you some clue about a malicious code. What is its functionality without you executing it. And then we have dynamic malware analysis, where we analyze the malware by executing it. So the target is for behavior analysis. We analyze the behavior of the malware so that at least we can be able to understand what is its impact on the host at the registry level, network impact, and also file changes to the system. So this type of analysis requires virtual machines and sandboxes to deter the spread of the malware, because you are analyzing the malware as you execute it. So debuggers such as GDB, OLIDBG, WinDBG, and etc. are used to debug a malware at the time of its execution to study its behaviors. So you debug it. So as it's being executed, you are able now to understand its flow, like what is the time, its entry point, then after the entry point in the computer system, what next does it do? So you analyze that. And there are also other tools that you are going to use. Maybe you are able now to understand the behavior, maybe on process on the computer system, changes to files, registry changes, network activity, and all that. So both techniques are intended to understand how the malware works, but different in the tools used and time and skills that are required for performing the analysis. Both static and dynamic analysis are recommended to better understand the functionality of the malware. When you are doing static analysis, majorly you analyze the binary code, provides information such as data structures, function calls, and call graphs. You load the binary code onto the test system. So here we are using the virtual machine that we have set up in quotes. So we just move it to the virtual machine, then we do static analysis of that malware. So at static, what we are going to do is just to understand the file, its header details, the hashes, embedded resources, packer signatures, and the metadata of that malware. So file fingerprinting is an important element whereby you take the hash value of the malware. So hash value is important because the mathematical calculation of a packed file. You just run a compacted file, then a hash is generated that identifies a malicious file. The hash could be an MD5, maybe a SHA-256. That's just fingerprinting the malware. When you fingerprint the malware, it's important. Maybe you can share the hashes with the other malware analysts so that at least they can also understand its functionality, or you can search it on the internet so that at least you can see, has it been identified by other people also. Then from there, you do online malware scanning, maybe using the hash. You can search on the virus total so that at least you will be able to understand, has this malware been discovered by other people? And are these all antiviruses on virus total are able to detect if this file is malicious or not? You have also to perform strings, whereby there are several tools that you use, like strings.exe, where it gives you the string, the values within that malware. So it just gives you an output of the specific strings within the malware, so that at least you'll be able to understand some key important strings that could be able to help you understand maybe the functionality of that malicious software. You have also to use different tools to understand if that malware is packed. We say malware packing is a compressed malware. So malware developers always try to compress the malware so that you as a malware analyst do not understand its functionality. Or you as a malware, and maybe a malware solutions that are there to detect the malware, like an EDR antivirus, they are not able to do that because the malware is packed or compressed. Obfuscation methods, they just ensure that maybe the malware is encrypted so you do not understand it. Then after that, you have to find the portable executable information. The PE header, it contains the information, different sections of a malware. So we have something called the R data, we have .section and maybe .data. It stores specific information about the malicious file. When it was maybe compiled, the compilation time of the malware, maybe the code, the tools that were used to compile it, and the importation, maybe what does it import when it's being executed, and what does it export when it's being executed. Then we also have to identify file dependencies. During file dependencies, we identify what does the file need, or does it depend on when it's being executed on the system. Then from there, we do malware disassembly. Disassembly is where we use tools like IDA Pro, OLIDBG, so that at least now we understand it at code level. So we are analyzing this malware without executing it. That's static analysis. So we are continuing with the malware static analysis where we do fingerprinting. It's recommended to compute the hash value for a given binary code before carrying out the investigation. So common hash calculators, you will be using hashtab, hashmyfiles, hashcalc, MD5sum, or MD5dip and etc. You can use the computed hash value to periodically verify if any changes is made to the binary code during analysis. So it's important to compute the hash because sometimes the malware tries to hide its activities. So when you are computing the hash at first, maybe it was showing a different hash, and maybe you tested that hash on VirusTotal. You are able to see that, but that there is not any antivirus among the antivirus total antiviruses that are there that was able to detect that this file is malicious. Then when you execute it, you see like maybe the hash is changing. So it's changing maybe now to show its real capabilities, its real behavior. So when you take maybe a new hash after it has executed, you compare, you'll be able to see that this malware hashes changed from the original hash value. So it means that it has a stealth way of executing itself without you being able to understand, of the computer system, security systems that are there like EDR and antiviruses being able to understand the functionality of that malware. We have online malware scanners. So already we talked about VirusTotal. So you get the hash value, or you can just go to VirusTotal and you upload the suspected malicious file on VirusTotal. It has different types of antiviruses. It's able to detect for you the type of malware it is, if the file is malicious or not. Then from there, it will be able to give you details about the specific malware and its suspected behavior. And you'll also be able to see if other people have already tested it or not, based on the time it was last tested. Strings, as I told you, sometimes you can be able to extract information from a malicious file. So when you generate strings from that, you extract the strings, you are able to understand some important strings that could at least give you a hint what is the functionality of this malware. So you analyze the embedded strings of the executable readable text, with the strings are just the readable text within the program's executable file. Use tools such as strings, resource extract, bin text, hex workshop to extract the embedded strings from the executable file. Ensure that the tool extracted strings are represented in both ANSI and Unicode formats. On extracting, you can see the input of strings of interest in search engine for more information. So if you use tools like maybe strings.exe or bin text, you'll be able to see something like this. Down here where my mouse is pointing, you'll be able to see these are the strings, information that has been readable text that has been extracted from any suspected malicious file. So when you're going through it, sometimes when you go through the strings, maybe you'll be able to see maybe it's mentioning maybe different packers that are used to pack the malware. So that one at least to give you a hint that maybe this malware is packed using the mentioned packer information, or maybe it's mentioning maybe some URLs. So you have that URL, maybe you can check it, or you can be able to identify maybe it's a malicious URL, or you can be able to mention some IP addresses that you will be able to check maybe and identify that those IP addresses might be malicious. You can also analyze the packing. Packing, most of the time, attackers often use packers to compress, encrypt, or modify a malware executable file so that the computer system does not identify it if it's a malicious file. Or sometimes they make sure that you, as a malware analyst, you do not understand its functionality. So it complicates the task of the reverse engineers in finding the actual program logic and other metadata via static analysis. So you have to use tools such as PEiD, which is able to detect if the file has been packed or not. So it will be able to show you the packer information. So that packed information, at least you will be able to understand, like this one, in this screenshot, you'll be able to see that nullsoft PMP SFX is the packer that has been used to pack that malware. So you are able to now to use other unpackers, other tools now to decompress the malware, so that at least you are able to decompress it, you unpack it, so that at least you can be able to understand its functionality, and also the EDR or the viruses can be able now to identify that file as being malicious. We have the portable executable information, which is just the sections of a malicious file. The executable files always stores metadata of a PE file inside the sections of the malware. So we have to analyze that PE header so that at least we are able to identify when is the compilation of that malware, so that at least we can be able to understand when was this malware compiled. because by any chance you are able to understand the malware that has been compiled of recent, you are able to understand that maybe it's a new malware, maybe it has not been detected by other solutions. Then when you analyze also the header, you will be able to see the functions imported and exported by the program. Majorly malwares run by depending on other functionalities. So imported are just the libraries that the executable is importing from other functions or other programs to be able to be executed on the computer system. Then exported is the one that it's exporting from other programs to run, majorly the dynamic linked libraries. Then also you look at the linked libraries, maybe the DLLs that are needed to be able to execute. Then you also see the icons, menus, version information, strings and etc. that are embedded in the resources. Majorly here we use, the major tool that we use is PEstudio, PEview, PExplorer, dependency worker, and etc. to extract the PE header information of any executable file. We have also to identify the file dependencies. Programs that store the import and the export function, majorly in kernel.32.dll file. So we have to examine the dynamically linked libraries in the malware executable file so that at least we understand which are these libraries that it depends when it's executing. And depending on the type of the kernel or the DLL, the library that is being used by a malicious file, you can be able to at least have a hint of the type of malware. If you see maybe like kernel.32.dll, it means that this malware needs the kernel to be able to execute. So in the kernel, what does it need? So you go deeper, then you'll be able to see its functionalities with the kernel. So we have to understand all the files that it depends on when it's executing. So the major tool that we use is called dependency worker, which lists all the dependent modules within the executable file so that at least we know which files it's depending on as being executed. After you have done with the basic static analysis, you have now to disassemble the malware. You dissect the malware at code level so that at least you go inside and understand each and every code so that at least you see the flow of the malware. You understand the flow of the malware by analyzing the code itself. So disassemble the binary code and analyze the assembly code instructions. You can use tools such as IDA Pro that can reverse machine code to assembly language. So based on the reconstructed assembly code, you can inspect the program logic and recognize its threat potential. This process majorly is you use tools like OliDBG, WinDBG, and IDA Pro to be able to understand the functionality of the code. So that's static analysis. And from there, once you understand the static analysis, now you go to dynamic analysis. So dynamic analysis is whereby you analyze the code while executing it. So there are several tools that we are going to go through so that at least we understand at basic static analysis, what do we do? At dynamic analysis, what do we do? And those different tools. Malware analysis is not too much content that you're going to cover. Once we just understand the different types of malware, how they work, and we come in and we understand how do we analyze them by any chance they get into the computer system. During analysis, provided we understand the tools that is used, each tool that is used at each level. Once you understand the tools that are used at static level, you are done. At least you can do basic analysis of the malware without executing it so that at least you understand its behavior. Then from there, you are able now to do dynamic analysis. You execute the malware by executing it. You analyze the malware by executing it so that at least you are able to understand its behavior. Then from there, you use tools like IDA Pro, OliDBG, and WinDBG to be able to disassemble the code so that at least you can be able to read and understand the code of the malware. Then from there, you are done. But for us to be able to understand very well about malware analysis, we need to do lots of practicals. We have to understand how do we analyze maybe a ransomware. Because when you analyze a different malware, there is always a different approaches that you follow. When you're analyzing maybe a Trojan, how do we analyze a Trojan? So also we have to do memory forensics by any chance the malware is in the memory. How do we do analysis? By any chance it's in the system. maybe EDR and the virus were not able to identify it. How do we do that? So we are going to do so many practicals about that. So you guys, you have to be going through the content on Soma so that at least you understand the basic concepts. Then we focus majorly on the practicals. So we also have to understand the Microsoft Office document analysis. Currently, most of the malware actors are trying to spread malwares through Microsoft Office document because they know that every human being today is using Microsoft Office. So they have seen that the best avenue to be able to spread malwares is through Microsoft Office documents. So at Microsoft layer, majorly at Microsoft Office documents, they always infect the malicious files using VBA macros. They're just visual basic macros that they embed into the Word document. So when you open it, you can be that malicious code, VBA code majorly, it executes itself. Maybe to be able to collect the information or download other malicious files, or majorly other times just to redirect you to other web pages. So you might be thinking that you are opening a Word document, but maybe there is some malicious code that has been injected in that Word document so that it's able to take the information from your computer system or maybe redirect you to another web page. So you are just clicking things, then you are on another web page that could be malicious, or it's there just to download other malicious softwares on the computer system without your knowledge. So once you find any malicious Word document, there are several tools that we use to be able to understand that malicious code within the malicious code that is embedded in a Word document. So here, maybe the tool that you'll be using is Remnax. Remnax, it has all the tools that you need to analyze Microsoft Office document and PDF documents that are infected with macros. So to analyze the suspected Office document, you have to use a tool called PEiD that is able to detect any specific components that can be labeled as malicious within our document. So it breaks down our document into sections. Once it's able to identify that sections, then within that it will be able to detect if there is any malicious macros. So if you use PEiD, then you are able to see maybe macro, VBA macros, then it might, and it shows that it's true, then it shows that there is an embedded VBA macros within that malicious file. Then from there, you find now where is the specific string of a Word document or Microsoft Office document that has been infected or embedded with that specific macro. So you use OLEDAM. OLEDAM helps you to identify the streams that contain the macros. So like the example that is given there, you can see that it has written 8. So that means that there are 8. Stream 8 has been identified to stop malicious macro codes. So once you see those macro codes, you can be able to dump them out from the system so that at least you can be able to analyze and understand what is their functionality. So there you have to use now a tool called OLEDAM. OLEDAM now dumps for you the macro code so that at least you can analyze it at maybe code level so that at least you see what is it. Sometimes majorly what they do, they always embed a malicious, maybe URLs, so that it's able to download other malicious files or still when you are saving maybe a Word document, it's able to be sent out to the malware developer. So using OLEDAM, you are able now to see the URLs, maybe the specific string, what it entails that the malware developer wanted to achieve in a Word document. So from there, you are able now to analyze using VBA keywords. So we pass the suspect document with all the VBA to view the source codes of all the VBA macros and detect the suspicious keywords and potential indicators of compromise. So you use all the VBA. The iOS can be able to be detected. So you will see all the iOS suspected maybe indicators of compromise. You'll be able to see the suspicious levels. Maybe you can see here the URLs that is embedded within the macros. that does now the real thing for the malware. So we are going to do the practical so that at least we understand all the tools that are used for Microsoft Office document analysis, so that by any chance you stumble upon a document that you suspect is malicious, then you can be able to do analysis so that at least you can be able to understand that. At dynamic level, we analyze the malware by executing it. So you run the malware so that at least you are able to analyze its real-time behaviors. So you have to see how it interacts with the computer system, you see the system properties, and also you see the network capabilities of that malicious file. So there are two approaches to dynamic malware analysis, where we monitor the host integrity and we observe runtime behavior. So at host integrity, what you are observing, it just involves taking snapshots of the system state using the same tools before and after the analysis to detect changes made to the entities residing in the system. So here maybe you want to see when a malware is being executed, what changes does it do on the computer system? Maybe majorly on the registry systems. Does it delete any registry file? Does it modify any registry files or alter them? So there are several tools that you execute them on the system where you are running. So these systems, these tools, we are going to execute them on virtual machine. So before we run the malware, we will run tools like maybe what changed. So it's able now to calculate the status of the system. Then once you execute the malware, again, you run it. So it will be able to generate all the changes that that malware has done on the computer system, so that at least you understand when the malware is being executed, what registry keys did this file, the malicious file, change on the system, which files were deleted, and what was the path where it was being executed from. Then you have to observe the runtime behavior. It involves just our live monitoring the behavior of the chosen malware as it runs in the computer system. So here we're using tools like Process Monitor that is able to monitor the process of the malicious software that we're executing. Then we have maybe Process Explorer, just explores the changes the process does of the computer system. Then we're also going to use maybe tools like ProcMon, now just to see from when the malicious file is executed, what next does it do on the computer system? Does it create other files? Does it maybe embed itself on another running application? Or does it start new DLLs within the computer system? Those are the things that we're going to monitor during dynamic analysis, so that at least we understand the functionality of the malware. So pre-execution preparation, before you execute the malware on the virtual machine, you have to create a fresh baseline of the forensic workstation. This is just to create a snapshot if you are running it in a virtual machine. You take a snapshot of the registry keys, file system, running processes, and event logs. Then you list all Windows services, device drivers, and startup programs. So that by any chance the malware, now you execute it, then you go and compare with pre-execution, so that at least you see, you are able to list, these were the listed services that were running. Maybe after then you are done executing the malware, you can be able to see the changes. Maybe there will be a new service that could have been added on the Windows services. Device drivers, maybe there is a new driver that will be added. Startup programs, maybe you will be able to identify there was a new program that was started after you executed the malware. You have also to install tools that will capture the changes performed by the malware on the system resources such as integrity, file system, processor, and etc., as well as network properties. You have to generate hash values of the OS and the tools, then run the malware on the forensic workstation. That's the procedure that you'll be following before executing it on the system. So there are several things that you'll have to do, so that at least when you execute the malware, your work is to understand its behavior. So every system at that time, when the malware has not been executed, you have to understand it very well. So by any chance, any changes are done to the system, you can be able to come and understand the registry changes that have taken place, the file system changes, the process changes, as well as the network properties of the computer. So host integrity, you can use a tool like what changed. So before running the malware, you have to run what changed. It's a software that you can run. Then you execute the malware. So you will save the snapshot. Then after executing the malware, you compare. When you compare, you'll be able to see the changes that the the malware did on the files and the registries of the computer. So that one will enable you as a malware analyst to understand that if this malware is executed, these are the specific key changes that it does on the host system. Maybe it's able to create some files within the system, or maybe it's able to delete some files, or maybe by any chance you're analyzing maybe a keylogger. A keylogger, when it gets into the computer system, first of all, what it does, it creates a text file maybe. Then it has a specific driver. It creates a specific driver that aids it now to allow RDP connection, so that the keyboard clicks that you are making, at least what is being collected is able now to send outside to the malware developer. So you will see those changes that the malware is able to do the computer system when you're executing it. So you use a tool called what changed. What it looks at is host integrity, the changes that the malware does on the computer system when it's being executed. So also you have to observe the runtime behavior, whereby when you're executing the malware on the forensic workstation, you have to observe its operation in real time to understand its intent and functionality. So you can learn about the behavior characteristic of the malware by monitoring its activities on the system and the network. Runtime behavior analysis of malware can be done in two ways. Majorly, you analyze the system behavior and also the network behavior. So system behavior, you analyze the monitoring, you monitor the registry changes, monitor the running processes, you monitor the services and startup folders, you monitor the event logs, monitor the API, application programming interface codes that the malware is able to do that. Then you monitor device drivers, you monitor files and folders. Then at network layer, you're only monitoring the IP addresses that are maybe the malware contacts while it's being executed, and also looking for ports that it uses to contact, and also the DNS entries that it makes on the system. This one will enable you to understand at network layer, to be able to understand if the malware is being executed on the computer system, which specific IP addresses or ports or DNS entries does it make. So you'll be able to see maybe there is some malicious URLs it's able to contact, the IP addresses and the destination, where maybe the source and the destination where the malware is trying to contact. So that one will aid you and help you to be able to see who is the person who is managing this specific malware and the location where that malware is being managed based on the IP address that you are able to identify. At behavior monitoring, malware manipulates the registry to ensure that it runs automatically whenever the computer boots or the user logs in. By running the malware on a forensic workstation, you can observe its activity on the registry and look for specific keys or values that are read, created, modified, or deleted by the malware. So look for Windows auto start registry location that are commonly targeted by malware to persist on the computer system. So they always try to delete the keys, maybe from 0 to 1, to ensure that maybe it becomes a malware that auto starts. So when you power on the computer, it persists on the computer system, like it starts up on its own. So you have to go through the key areas of the registry. When you analyze the software, maybe current version and run, you'll be able to see the keys that were altered. Startup keys, majorly you analyze the software registry files still, where you see the shell folder, user shell folders, where you will be able to see the changes with the startup programs that are there on the computer system. You have also to analyze auto start registry keys. Majorly you use on computer system when you are running it. By any chance it's a computer system that has been infected with malware, you collected the NAT_user.dat. It's a registry file that stores all the registry keys of AutoStart for every user that logs into the computer system. All the activities are stored in the NAT_user.dat. Majorly, it's found in the folder of the user application. Like you go to users, then you click on the name of the users that are within the computer system. But then when you click on the name, you will be able to see a file called NAT_user.dat. It's a registry file that stores all the activities of that user on that computer system. So when you analyze that, you'll be able to see which applications were auto-started by that user and which are configured to auto-start by that user when they log in. You can use tools like process monitor. So you process monitor shows real-time file system registry and process thread when you are executing the malware. So it will show you like this one is the malicious file that is being run on the computer system. So it will be able to show you the changes that that file is able to do. Maybe it's creating other file. It's able to query a specific file, or it's able to change the registry keys. You'll be able to see that one in real time using process monitor. There is also monitoring Windows services. When you monitor the Windows services, you'll be able to see the services that have been started by the malicious software. So examining Windows services upon malware execution helps in identifying any suspicious services created by the malware that might run automatically or require manual intervention to get started. You also have to monitor startup programs. Malware can alter the system settings and add themselves to the startup menu to perform malicious activities whenever the system starts. So steps to manually detect hidden malware. So you check startup programs entries in the registry. You can go to System 32 and you check the drivers, where you'll be able to see automatically loaded drivers. You check maybe boot.ini, where you'll be able to see the boot manager entries. You check startup Windows services where you go to run, then you put services.msc and you'll be able to see the startup type application. So it will show you all the startup applications. Autoruns for Windows. Autoruns for Windows displays programs that are configured to run automatically during user login or system boot and can help detect malicious startup programs and processes. So you can use a tool like Process Explorer that gives you the information about the autoruns. Or there is an application for sysinternals. Sysinternals are applications that are developed by Microsoft that helps you to understand the Windows operating system. So if you're using Autorun, you are able now to see all the listed applications that start when a computer starts or when a computer boots up. Monitoring Windows event logs, you can be able to monitor the Windows event logs, so where we'll be able to understand the different logs that are there. So usually Windows built-in event viewer utility to monitor events based on specific details, such as event ID, event name, event description, and it is to look for malware indicators on the computer system. Monitoring API calls. Malicious programs often make use of Windows APIs to access operating system information such as file system, thread registry, and kernel. API call monitoring helps in understanding a malware's interaction with the OS and might provide valuable information regarding its system and network level activities. So use tools like API Monitor to intercept API calls made by the malware during its runtime. Monitoring API calls in continuation. The examination of the API calls made by the malware upon execution by API monitor tools reveal maybe the malware has repeatedly used create file anti-create file function to create malicious files in the system folder of the Windows forensic workstation. So it will just show you the locations where maybe by any chance it was able to create a malicious file or create other remnants of files. You can be able to analyze them using Windows API code so that at least you understand the changes and the files that were created by the malicious file when it's being executed on the computer system. So you have also to monitor the device drivers so that at least you'll be able to understand the drivers, maybe suspicious drivers that were able to be installed in the computer system. So during verification, you'll be able to see which are the genuine downloaded drivers and which one are fake the drivers that were used by the malicious software. Drive view. So drive view displays a list of all device drivers currently loaded on the system. For each driver in the list, additional information such as the load address of the driver, description, version, product name, and the company that created the driver is always displayed. So here you can be able now to identify any drivers that you think could be malicious within the computer system. You also have to monitor the files and folders so that at least you be able to understand maybe the changes, maybe the alteration or modification that were done to the files when the malware was being executed. Well, most of the time, the tools that are used is SIG Verify, FBI, FC4, then we have Tripwire Enterprise. Majorly, these are just check the integrity of files within the computer system to see if there was any changes to those files or not. by any chance there were any changes, then they will be able to show the specific timeline that the files were altered or modified and which specific application that was able to change those files. So when you analyze that, by any chance there is any malware that is able to change the files and folders, you will be able to see when it's being executed any changes that is able to undertake on specific files within the computer system. We have PEiD site is a file monitoring utility that audits which user application is deleting files, moving files, or reading files. It can generate reports with details such as user account, including the domain, active directory, user computer name, targeted file, and folder. Then we have active activity done on the file, date and time of action. This is important. By any chance you are executing the malware, you'll be able to see by any chance there is any external entities that are able to have access to computer files within the computer system. So maybe when a file is created, maybe when a malicious file is being executed, maybe there is a remote connection that is done. So it maybe could aid an external person to have access to computer system. So PEiD file site just ensures that by any chance maybe there is new accounts that are created, then you can be able to see the activities that they did on the computer file system. Maybe if by any chance they were able to read, write, or delete the file, then you will be able to see and also be able to see the user account that was used, even if it's an RDP account. We have FATSAM and WinMD5. So WinMD5 is a Windows utility tool for computing the MD5 hashes of files. These fingerprints can be used to ensure that the file is not corrupted. By any chance, malwares can be able to change the files or can make other malicious files within the computer system. So they can find maybe one document, so they change the document setup. So by maybe embedding maybe the macros inside that file, so that it can now aid another malicious entry into the computer system. So if you have computed the hashes of all the files on the computer system, then you can be able to compare them so that at least you ensure that the computer system are not corrupted. By any chance they are corrupted, now you understand that they have failed the integrity of the files, so that at least you understand when were they modified and which specific maybe application or process was the one that maybe then made the changes. So those are the key things that we are going to understand. So those are the key tools that you guys are going to use majorly to understand how malware analysis works. So I'll be sharing the notes, but what we are going to focus on is to do the practical, so that at least we analyze at least a minimum of five different malwares, so that at least we critically analyze them and understand their functionalities. So that's the end for today, unless there is a question. Virus total majorly is just for us to understand the capabilities of the malware, to understand its behaviors, but it doesn't cure, it doesn't remove the malware from the computer system, because it's just a web page whereby it has all the antiviruses. So it just used majorly to analyze it, to detect. Then, if by any chance the malware has already been detected before or analyzed by another person, then it will be able to give us the behaviors of that malware and the different names maybe the malware has been used to identify itself. So members, we meet next time or maybe over the weekend, so that at least we can be able to set up a virtual machine, so that at least we go through the procedure of setting up a virtual machine. Then we be able to analyze one malicious file. It gives you information about the malicious file, virus total. It gives you information about if it's a known virus. If it's a known malicious file, then you'll be able to get information from it. Yes, good. Alan has answered very well. So that's it for today, guys. So we're just to do the theoretical understanding of malware forensics and malware analysis, so that at least we understand it very well. Then from there, we deep dive ourselves into practical, so that at least we do more practical analysis of malwares, so that at least we are able to understand the key things about malware analysis, so that by any chance you are facing any incident response, you are capable and you are able to go and analyze any malicious file and be able to understand its functionality and document a report, a malware analysis report. So all the best, guys. We meet next time.